Right, 2012, day 1, question 3. Simplify fully. 4x cubed times 4x cubed, 4 4s are 16, x to the power of 3 plus 3 is 6. Part B, I'm going to add 2x to both sides first. Minus 6. And divide both sides by 5. X equals 1/5. Right, part C, that's quadratic, and we know with quadratics we want to try and get 0 on one side, so we'll need to minus the 6. What you do to one side you do to the other. I'll definitely get 0, and on the other side we'll have 2x squared minus 5x minus 6. Minus 6 is minus 12. Now we need to factorise. We could look for a common factor first, but unfortunately 2 doesn't go into 5, so that makes it a bit tricky. 12 also has lots of factors. I'm going to use the gate method, 2 times 1. And for 12 we can have 3 times 4, 2 times 6, 12 times 1. Well, we really just have to get in and try something. Let's try the 3 and the 4. 3's are 6, 4 1's are 4. It's not going to have a difference of 5. Cross it over, 2 4's are 8, 3 1's are 3. Well, that would have a difference of 5 if we made it minus 8 and a plus 3. So let's try and put that information into brackets. I want a 2x and a 1x. I want the 2x to be multiplied by the 4, and in fact I want it to be minus 8, minus 8x, so we need the minus there, and the 1 to be multiplied by 3, positive 3. Now you can check that. 2x squared minus 8x plus 3x would be the minus 5x. I certainly get minus 12 on the end. Right, so solving that, looking for a value of x to substitute into this left hand side so that when I multiply the two factors together I get 0. One of them is obviously x equals 4. We need to think about this one. Clearly x needs to be a negative number, a fraction. And if you find this difficult, you could go to the side of your page. We're trying to think of a value for x so that 2 times it plus 3 equals 0. That's a little linear equation now. 2x will be negative 3, minusing 3, dividing by 2. We get x equals negative 3 over 2 is the other solution. Not a lot of space for working there. $7 a day and $1 per kilometre. So $7 times the number of days plus $1 times the number of kilometres. 7d plus k. $185k and should pay your friend 213. Find the number of days. So 7d plus, she travels 185 and she ends up paying 213. 185 times 1, remember it was $1 for each kilometre. Now we need to minus 185 from that. 15 up to 200 and another 13 would give me 28, which is nice, so d equals 4. Just check. You might write a sentence. Sarah used the car for 4 days. Right, Emma is 3 times as old as Tara, so let's think about that. Emma and Tara. Emma is older. Emma is 3 times as old as Tara. In another 7 years, Emma will be twice as old as Tara will be. Emma's age now. Well, if we let Tara be x, Emma is 3 times as old. So Emma must be 3x, because she's 3 times as old as Tara. So if Tara's 10, Emma is 30. In 7 years' time, she will be 3x plus 7, and she will be x plus 7 years old. In another 7 years' time, Emma will be twice as old, so she will equal 2 times Tara's age. So there's my equation. I'm sure there are other ways to do it. As long as you end up with the same answer and you do use at least one equation when you're working. Minusing 2x from both sides. Minusing 7. So that would be, and now we can just check Tara's age now. So Emma would be 21. In 7 years' time, she'll be 14. And she'll be 28, and in fact she is twice as old. So Emma's age now must be 21. Emma is 21 now. You could have got that a different way, but you just have a look at your working, make sure you've got an equation. Part F, x to the power of 12 equals y. Let's work that out. Express s, so we want x equals. I could write this as x to the 6 times x to the 6. So, well, actually there are other ways to do it. Let's think about this. I've got 12 x's here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 multiplied together. And that is equivalent to 6 y's multiplied together. We use dots for multiplication. Now all the y's are the same and all the x's are the same. So it looks fairly clear that each x times x is going to have to equal the same as a y. In other words, x squared is going to have to equal a y. We want it to say x equals, so x must be the square root of y. We'd need to consider positive and negative values, especially the fact that they're all an even number of power. We'll just check if x equaled the negative square root of y, then x times x would equal, which is y squared, which is okay. So yes, I think the full correct answer would be x is the square root of y, but there is a positive and a negative.